Hey guys, so let's start. Okay, let me do one thing, copy it and open. So guys, yesterday we have seen till this point, these two commands we have done router EIGRP number one. So I'll quick review. The ACE number is a 32-bit, sorry, ACE number is a 16-bit of number. And this is the logical group of router, right? And in a logical group, in a logical domain, right? So this is my logical domain. We have a multiples. Come on, this is my logical domain, and we have a multiple routers of.
Sorry to interrupt, love, but quick question. You're going to let us know, like, what is the implication of having duplicate RID, right, in EIGRP?
No, not today, right? That's a very that's it. Once we have done with the this part, like
Okay,
filtering and those things, then I'll discuss that part. Okay, don't worry about
got
that.
it, got it. Okay, thanks.
Okay, so this is the like a logical group, and we have a logical group identifier over there. It's the AS number one, and this is the router number one, this is the router number two, and this is the router number three. To identify this router in this logical domain, right? Listen, to identify this router, and this router in this logical domain, we need to put some identifier, or that identifier is known as a router ID, and it is a 32-bit number, and it has to be unique, right? Like it's always recommendation to use this router ID unique. Okay, it's a 32-bit number you can use from this range, right? 255.255.255.254. You cannot use this guy and this guy. This is totally reserved, right? So take example, what is the router ID election criteria was there? All right, come on, RID election. First, it will go for the manually. Second, it will go for the highest loopback interface IP address, and the third is the highest physical interface, right? And if you don't take example, I don't have any loop back, not I have defined the manually, and not even I don't have any physical interface, then router ID will be 0 or 0 or 0 or 0 or 0. It means that the router did not, or we can say that this EIGRP did not elect the router ID. Now, so there is a three use of this command. Once the first one is use this guy is like, you can enable the EIGRP. Second, you can create the topology table. And third thing is that like RID. Now, take example, there's a two-person over there, right? Okay, and this is Rohit, right? And this is Nidhi. Try to understand this. These two guys are present in the Bangalore location, right? In the Bangalore airport. Okay, and both are a stranger, right? Just pay attention, guys, over there. Both are a stranger right now. Rohit does not know anything about Nidhi, and Nidhi does not know anything about Rohit, right? Both are a stranger. Now, this guy, this Rohit has some magazine, right? Some magazine they have. The childhood they have magazine called a Champak, something like that, right? So this guy has a magazine. So what happened? Try to understand. Nidhi has seen some magazine opposite of the Rohit, and this girl wants this magazine. So what happened? Right now, they don't know each other. Both are a stranger, right? And they are just in the Bangalore airport. So this girl will initiate the communications. This girl will say that, hey, or get a hello, this is Nidhi, right? Try to understand. If Rohit understand this language, listen to me. If Rohit understand this language, because maybe Rohit don't know about the English, right? Who knows, right? Maybe this guy only know the Hindi, maybe this guy only know the Tamil, maybe this guy only know the Punjabi. If Rohit understand this language, or if Rohit agree, then it will say that, okay, hello, this is Rohit. So what happened? The common thing about this guy, if you see, we have a hello. And what is the use of this hello? Like a hello or hi or hey. This is the initial start, like an initial establishment of the neighborship. Without extending the hello, if you're just making a call to someone any else, right? What the first word is the hello, right? What hello is doing over there? Just making establishment of the communications. Once you have done with the like a neighborship, now we have a friendship. Now they can exchange this information, champak information to the Nidhi. Without neighborship, they can't do that. In the neighborship, what happened? In the neighborship, both the person has a knowledge about the both. So now the Rohit has a knowledge of the Nidhi and Nidhi has a knowledge of the Rohit. Previously, it was not. Same thing happened with the EIGRP guys. Whatever the route behind the R1, right? And whatever the route behind the R2. If this two router wants to exchange this information, or we can see that if this two guy wants to communicate to each other, if this two guy wants to communicate to each other, right? First of all, what happened? This two person has to establish the neighbor relationship. And this neighbor relationship is called as a EIGRP neighborship. So once they will form the EIGRP neighborship, now what happened? R1 has a knowledge about R2 and R2 has a knowledge about R1. Same like that, once the Nidhi has exchanged the own information with the Rohit and Rohit has exchanged with the own information with the Nidhi. So Nidhi know who is the Rohit and Rohit know who is the Nidhi. Same thing. Now, once they will form the neighborship between the R1 and R2, what happened? R1 knows about the R2 and R2 knows about the R1, not detailed information. Like you and me right now. You don't know me and I don't know you. First of all, what happened? We need to exchange the hello. Once we have done with exchanging the hello, now what happened? Both the router will form the neighborship. What I told you, if you remember the, like, the first day, the routing batch, your interface is behave like what? Your interface is behave like a gate, a door, right? We can say that.
Interface behaves like a gateway, right?
Yes, right. A door. So right now, this interface has no idea about EIGRP, and even this interface has no idea about EIGRP. So this interface is blocked, and this interface is blocked in the perspective of EIGRP. Like these two guys are totally dumb. These two guys are totally dumb in the perspective of the EIGRP case. I'm not talking about the ping. They can ping to each other right now. 12.1 can send the traffic to the 12.2 and 12.2 can send the traffic to the 12.1. I'm talking the perspective of EIGRP case. These two guys are dumb. They will not able to understand any EIGRP packets. What happened? I need to open this gate. And how do I open this gate? By enabling this interface into the EIGRP routing protocol. So that once this interface will be enabled in the EIGRP routing protocol, now this guy will send a, hey, I want to form the neighborship with you. And it will send the hello packet. The first EIGRP packets hello packet. Now the EIGRP will send the hello packet to the router number 2. And how this interface will enable in the EIGRP? I need to manually enable this guy. I need to go in the network statement and I just say that, hey, network 191.6.12.0. That's it. Once I put the network statement, what happened? Now this interface will be enabled in the EIGRP, and now this guy will send the hello packet to the router number 2. And this hello packet is used to form the navigation. Seem like a normal example, right? These two guys, right? Nidhi, Rohit and Nidhi, they are exchanging the hello, right, to form the navigation. At the same time, once they form, after that, router keep exchanging hello packet at every 5 seconds to maintain the navigation. So first it used to, like, what we call over there, form the neighborship. And after that, once they will form the neighborship, right? Now this guy is going to use to maintain the neighborship and they will extend the hello packet at every 5 seconds. So what is the use of this network statement? The use of network statement, the first use, it enable the interface into EIGRP, or we can say the protocol, whatever the protocol we have, either EIGRP or other step, right? It join the multicast group, and third, it put the route into topology table, and fourth is what, it advertise the route. This is the four use of network statement. So once I have enabled this guy, right, interface 0/0 network I2S to the 12.0. So whatever the IPs are present in this interface, can you see that the IPs will be near around 12.1 to all this IP, because the 12.0, right, the first is a network ID and the last IP is a broadcast IP. So all this IP will enable into the EIGRP routing protocol. If you want to enable the only specific, you can also enable. But if you want to enable the complete network, I'm just going to give you the very basic introduction right now, how does network extending works over there. Once I put this command, what happened now, router number one, this interface is going to join which multicast group, 224.0.0.10. And in this group, which router is there? R1. So R1 will keep sending the hello packet at every 5 seconds to the router number two. And what router number two will do, it will drop the packet. In this case, what happened, the hello packet will look like this. We have a source MAC address of this interface, MAC address A. Destination MAC address will be, the multicast MAC address of EIGRP 0001 5E 0000 and 0A. A reserved multicast MAC address for the EIGRP. I'll let you know how this multicast will be calculated in the multicast chapter. But yeah, this is the reserved MAC address for the multicasting. Then after that, we have our type field will be 0x0800. That's going to represent that, hey, I need to forward the packet to the layer 3. That's a 2-byte field. As we know that every, the layer has an information about above layer. So this type field is going to represent, I need to forward the packet to the layer 3, right? So now the layer 3 will be source IP will be 12.1 and distance IP will be what, 224.0.0.10, right? And then after that, EIGRP. Okay, before the EIGRP, we have a TTL concept over there. The TTL will be what? The TTL will be over there. It will be 2 or it can be 1 as well as. Right on this point, guys, in a 12.0 as version, the TTL value will be 2, and in the 15.0 as version, the TTL value will be 1. And then after that, we have a EIGRP protocol number will be 88 IP. And now after that, we have a EIGRP header, and in this EIGRP header, we have a hello packet. This information now R1 is keep sending at every 5 seconds. He's just trying to form the negotiation with the R2. What R2 will do, they will just drop it because this interface is not enabled with the EIGRP. On this router, we just put this command, right? Router EIGRP number 1. That's it. What this command is doing, this command is just going to create this thing. But if you want to enable this interface 0/0, what we have to do, we need to do this thing. So that's why R2 is dropping the packet, because this interface is not a part of the multicast group. If you have a look, R2 console, capture this link as well as, and I have a look back over there. EIGRP is a guy's classless routing protocol. They do have a subnet mask information in the update packet. Interface 0/0 12.1, and IGRP has replaced with the EIGRP in the 1993, because in the 1993 they introduced the concept of classless.
Um,
Law, if you don't give any subnet mask, will it not take the
Of course,
interface
that
command?
will take. That's why I'm just giving the basic right now. I am not done right now. Just wait for some minutes.
Okay, okay.
Lo, I have one more things to ask. Classless and variable length subnet mask is also
Yeah,
VLSM, right?
VLSN and FLSM.
Oh,
Yeah, tell me. Yeah. So if you see, I just defined the routing EIGRP. We have a 16-bit of AH number. Put the command, and what happened? Do show IP EIGRP closing. The router ID will be 101, the highest loopback, right? And if I want to the network, and before the network, I'm going to do the do debug EIGRP packets. My hello is enabling the debug, right? And now if you see, I said the network, what happened? R1 will keep sending the hello packet from this interface at every 5 seconds. What R2 will do? R2, are you able to see? I just put the command router EIGRP number 1. What happened? They will select the EIGRP topology table and they have a router ID. That's a 2.2.2.2. It's a loopback of R2, right? But if you see, do debug EIGRP packets, am I getting any hello packet over there from my neighbor? It's only sending, but R2 is dropping because R2 is not enabled with the EIGRP. If you have a look on R1, see, do show IP interface 0/0 and see this output. What happened? Do you all? No. R1 had joined the multicast group, right? For use, right? The for use is what? They will join the multicast group, enable the interface into the particular routing protocol so that they can send the hello packet, and he's sending, right? It put the route in the topology table. See, I have this information in your topology table, 12.0. Don't worry about the passive successor. I'll explain you later on. Don't worry about that. Everything is there, right? And this guy had joined the multicast group. And if you see, 12.1 is sending the packet, right? Source MAC address of the router 1 MAC address, C201. Awesome, right? Destination is a multicast MAC address 01005E 0000A dot 10, right? Mapping the hexadecimal A10. Type is a IPv4. I need to forward the packet to the layer 3. Source IP is 12.1, destination IP dot 10. Reserved IP for the multicast, sorry, EIGRP, class D. See, the TTL is 2, right? What iOS version I'm using over there? Guys, just a small point, just write on this thing is a 12.4, the TTL is 2. What's our EIGRP protocol number? 88. And now all this EIGRP packet is going to be encapsulated with the IP header, right? And now this is the EIGRP, we have a hello packet. This keeps sending. Are you able to see any packet that's coming from the 12.2? Only the 12.1, because right now, in my case, what happened? R1 is keep sending, but R2 is dropping, right?
Yeah.
What
R2
I have to do, I have to enable this interface into the EIGRP so that they can understand the EIGRP packet, and now they will form the neighborship. And that, how do I do that? Just putting the network statement over there. So now if you see over there, R2, I see that network, I can enable the single interface as well as match the single interface with the wildcard bits. Now what happened? Once both the router will exchange the hello packet, sending and receiving, it will form the neighborship. Can you see that? Now R2, this router, this interface has joined the multicast group. If you see do show IP interface 0/0, all good. So now it means that now this guy understand the EIGRP packet because this multicast group is reserved for the EIGRP. And now if you see when R1 is sending the hello packet to the R2, R2 is receiving from my neighbor 12.1. At the same time, I do have the ability to send it. So now it's a bidirectional, right? So I do have a neighborship between this guy with this guy. At the same time, once the router 1 is going to form the neighborship with the router number 2, immediately what happened? They will form the adjacency as well as. This adjacency is a logical connection, guys. Adjacency is going to tell you, hey, now they can exchange this information. In a neighborship, what happened? Rohit just has a knowledge about Nidhi, and Nidhi just has a knowledge of the Rohit. That's it. Adjacency means what? Now I do have ability, I can share the information with you. So in EIGRP routing protocol, guys, in EIGRP routing protocol, every router form the neighborship and adjacency. But in the case of OSPF, not every router form the adjacency, but all the router can form neighborship. If you know the DR/BTR concept, that's good. Otherwise, just write on this point. This is the difference. And once we learn the OSPF, then you will have a clear picture of this thing. This small point, you do one thing, just write on in the small like a pages and paste in front of you, right? So that you can easily, differentiate the protocol between the EIGRP and OSPF difference. And now if you see, I have a EIGRP neighborship. You see, R2 has a knowledge of the R2 right? Don't worry about this part. All those things we are going to discuss, right? Don't worry. Everything is there. Okay. I'm just trying to show you the basic, like how they are forming the neighborship. Once they form the neighborship, what happened? At every 5 seconds, right? R1 and R2 is going to exchange the hello packet to just maintain the neighborship. To just maintain the neighborship. Can you see? I'm sending, receiving, sending, receiving, sending, receiving. So R1 is sending and R2 is also sending. So they are sending and receiving. Bidirectional is happening.
Excuse me, sir.
Yep.
Sir, in that packet, can you tell me the TTL thing, sir? Some TTL2 you told.
Yeah. So TTL is 2 in the 12.0 as version.
12.0.
12.0.
Okay. Okay, sir.
In 15.0, it should be 1 over there.
Okay.
So if you see, you all show IP EIGRP neighbor. What's my hold on time? It's a 15-second, right? It's 9 seconds. It's a 15-second over there. The hold on time of EIGRP. What happened? Take example, when the router 1 is sending the hello packet to the router number 2, right? Take example. And right now the 10-second is happening. Once the router number 2 will receive this hello packet on this particular interface, they will reset this hold on time 15 seconds. And now again decreasing 14, 13, 12. Again, R1 will send the hello packet. R2 will receive on this particular interface. They will reset to the 15 again. Again, 14, 13, 12, 11, 10, 9. Still, R2 is not received the hello packet from my neighbor. 8, 7, 6, 5, 4, 3, 2, 1. And once it becomes 0, right? It means that what? R2 will declare, hey, my neighbor is dead, because I haven't received any hello packet from my neighbor. So your hello packet is like, that's a keep alive, right? They're just going to keep informing my neighbor, hey, I still up, 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 I still up. If you're not sending me, I will declare you are dead. So if you have a look over there, I'm going to shut down this interface, right? So that they will not send any hello packet to the router number 2. And now go on R2, show IP HRP neighbor. What's the timer? 12. Still, I have a neighborship, right? 8. Still, I have a neighborship. 6. Still, I have a neighborship. 4. Still, I have a neighborship. 3. I'm just waiting. 0. And now you see, I got the neighborship down. So the hello packet, right, is used to form the neighbor relationship. At the same time, router keep accessing the hello packet to maintain the neighborship. If this thing is not there, then how does R1 will know about R2 and how does R2 will know about the R1? This is not happen in RIP case, guys. And now, if you have a look, now R1 can share this information. Go on R1, and I can router HRP number 1. I can inform this guy to the router number 2, and router number 2. If you see, come on, I don't have a look back. I must have. Okay, interface is done. So on a router number 1, I have advertised this network, right? 1.0.0. So now R1 will share this information to the R2. Which information? 1.0.0.0.0 slash it. So what is the use of network extender over there? This interface will be enabled. Which interface? Look back number 1 will enable in the EIGRP. They join the multicast group. A router will advertise this information. At the same time, they put this information in the topology table. All this 4 thing will happen if you go back to the R1 and check do show IP EIGRP interface. This interface is enabled in the EIGRP, right? Look back number 1. That is this guy. Then do show IP interface loopback number 1. This guy has joined the multicast group .10. And now at the same time, do show IP EIGRP topology. I do have this information in my topology table. At the same time, R1 is going to share this information to the R2. And now R2 will have this information in the routing table. D4 EIGRP, right? Show IP root. And all good. 90 is the AD, right? That's a AD for the EIGRP.
80 for EIGRP, yes.
I'll explain in this part later on. We'll see that, okay, the metric concept. And now I'm receiving this route from which neighbor? 12.1. How many seconds ago? 58 seconds ago. On which interface I'm receiving? On 0/0, my interface. So this is the R2 interface, my interface I'm receiving. So R1 is sending this packet to the R2. And in this packet, they will have this information and they will receive on this particular interface. From which neighbor? 12.1, that is this guy.
And 90 is the 84 internal EIGRP, right?
Yes, if you know, that's good. We'll discuss this thing again. We have, I'll tell you, we have a update packet almost all, we have 1+ hour of the class, right? Okay, so don't worry, that's internal, external, we'll see that later on. What is the important right now? I'm just trying to say, I'm just giving the overview right now, how actually the EIGRP is working, right? If you're not basic, the CCNA level things and stuff, I'm just giving you right now. And now if you see, I can send my traffic to this guy, right? Same thing if you go back to the R2, and on R2, if you advertise this route, done. Now R2 will share this information to the R1, right? And R1 will maintain this information in the routing table. Done. And now we do have a end-to-end reachability. Good.
Hello,
Also, yeah.
can we go back to the OSPF and EIGRP, the one that you typed in there?
Okay. Yeah.
There in EIGRP, every router from neighborship, but in case of OSPF, not every router, but all the router can form. What is it? Sorry.
Adjacency, I said it. This is the point. Did you get this one, Kat?
Can you explain that again?
Yeah. Why not? Do you have an idea of the DR, BDR of the OSPF? No?
I'm sorry?
You have an idea of the DR and BDR in OSPF? What is DR and BDR?
DRBR.
Yeah?
Yeah.
Oh,
Yeah.
that's great. Then it's great. Come on. Come on. Copy paste. Done. So this section is the EIGRP that I'm running over, right? And this section is running the OSPF. So in the EIGRP, what happened? R1 will have a 4 neighborship, right? And 4 neighborship and 4 adjacency. Same thing, R2 will have, R3 will have, R4 will have, and R5 will have. Because R1 is going to form the neighborship with this guy, this guy, this guy, and this guy. At the same time, adjacency, neighborship and adjacency, neighborship and adjacency. Same thing, R2 will form the neighborship and adjacency with this guy, and this guy as well as. Same thing, R3 will now form the neighborship with this guy, this guy, this guy. Same thing, R4 will form the neighborship with this guy. So already the R4 has a neighborship with R3, no need to form. You can see that it's like a full mesh. Every daughter is forming the neighborship with every daughter and adjacency as well as. Both the things, every daughter has a 4-4 neighborship. But in the case of OSPF, what happened? Take example, this is my DR daughter, right? And this is my BDR. What happened in this case? R1 will have a, the 4, not 4, R4 will have a 4 neighborship and 4 adjacency, right? Same thing, R5 will, R4 also have the same information, but if you go to R1 will have only 4 neighborship, but 2 adjacency. That is the DR and BDR. Same thing, R2 will have a 4 neighborship, but 2 adjacency. R3 will have a 4 neighborship and 2 adjacency. So it means that the R2 will form the neighborship with every person, but adjacency they will have only with this guy and
I see.
this
Thank
guy.
you. Thank you.
Excuse me, sir.
Yes.
Sir, what do you mean by adjacency, sir?
Adjacency means what? Now I'm going to share the information. It's a logical connection between these two neighbor, right? It means that now both the router can exchange the information about itself. Neighborship means what? They just have a knowledge about the neighbor. I know the R2 and R2 know the R1. They cannot exchange the information directly.
Like periodic updates.
Yup, like a periodic updates. In this case, take example. R1 is having a 1.0.0. So R1 is having a neighborship with every person, right? R2, R3, and R4 and R5. But R1 cannot exchange the update with the R2. They will first share the update to the DR and BDR. And now then DR will flood the information to this guy.
Okay.
That's the meaning of adjacency. But in the case of EIGRP, what happened? If R1 has some update 1 or 0 or 0 or 0 or 0, they can say they know to this guy, this guy, this guy, this guy, this guy, this guy, everyone.
So
Wastage of resources is happening.
So we can say it like this, that um, in EIGRP we have both the neighborship table and the routing table. Both have all the neighbors and adjacencies. But in OSPF, the neighborship table has all the network, all
But I
the
told you that adjacency is
routers.
a logical connection, man.
Yeah. So in OSPF would be like the routing table has only two. Uh, uh, what do you say, two entries, but the neighborship table has 4 entries. Can we say it like that?
Adjacency entries you are saying, guy?
As routing table.
No, you are wrong.
Okay.
I think adjacency will be there with everything, but only the DRBDR it will not be with every single neighbor. I believe in OSPF in a
No,
broadcast network.
like this guy know the R1 knows the adjacency with the R5 and R4, right? So if R1 is what DRO. So if R1 will receive any information, they cannot say the information directly to the R2. Never, because you are also a DRO, right? I can only share the information with the DR and BDR, and now they will flood the information to you. That's the meaning of adjacency is happening. I'm just reducing. Can you see that? Do we have a full mesh connectivity over there in the OSPF? No. I'm just reducing the overhead. That's the main difference between the EIGRP and OSPF.
Link state updates on OSPF.
Yep.
Okay, so it's going to be like it's always a full mesh in EIGRP, not an OSPF, basically.
Yeah, exactly right. That's point. That's the main point. That's why we have introduced the concept of DR and BDR, buddy. This is the reason. And this is the reason why, this is the one of the reason why we are preferring the link state protocol in the ISP network for a big enterprise network. Can you imagine if you have 100+ router in your subnet, right? In this like kind of network, it's a broadcast network. If you are running with the EIGRP, how many load will be happen? And if you're running with the OSPF, which one is better? Of course, this one. These are many reasons. We'll see that in the OSPF part. This is the one of the reason, the main difference between the EIGRP and OSPF. Clear now? Any questions? Yep.
All good.
If you have a look over there, I'll do one thing. I'll connect a 115.0 as version over there. Interface 0/1 IP address will be 23.13.1/24. Nodes are done. Route EIGRP number 1 network 23.0. Okay. Interface 0/0 IP address will be 23.13.3. I can advertise the sky 23.0 now, and now looks good, right? I just want to try to show you something. Okay, network 13.0. I want to try to show you something else. So 13.0, and now you can see the
I think in R1 also you gave 23.0 network.
wow. So if you see this link, so they form the EIGRP neighborship, okay, and at the same time I'm from the neighborship and adjacency as well as. Guys, these are the like very small things, right, that you have to pay attention over there. Just write on this part, take a screenshot, right, and you have to see the behavior in the OSPF. It's different. And if you see the 13.1, that's not this guy. I want 13.3. I want to see that. Not this 13.3. That's happening. If you see the what's the TTL value is happening, 1, and what's the TTL value for this guy, 2. That's the main difference between the you're deploying the EIGRP between the two different versions.
No, so that means this router has iOS version 15.1 more than
Yeah.
15. And can we say like adjacency is something like the link status? So I'm monitoring the link live.
Yeah, you can say that. Monitoring the link flag. That's something of agency. If your neighborship, but again, it's a logical connection, right? It's not more going to monitor. Monitor is only going to monitor neighborship, not the adjacency is monitoring. It's only monitoring the neighborship.
So, Love, what is the implication of having a TTL of 2? Is it basically that they don't have to be directly connected?
That's why. That's a like I just want to ask you from you guys. Any reasons do you have why they made the TTL 2 to 1?
Okay, so the latest version is 1 basically, right? So it has to be directly connected.
What's the reason? That's my question. What's the reason?